This is the video for 4-6 relations and functions. Please pay close attention to your assignment sheet because you will notice I am not going in order in Chapter 4 for various reasons. But let's start by going over our vocabulary. What exactly is a relation? A relation is a pairing of numbers from one set called the domain to another set called the range. And I have an example here of a relation. What is a domain? A domain consists of all of the x values, and that is known as your input. And so in my example, the domain is going to be 1, 3, and 4. And the range is going to consist of your y values, and that is known as the output. And so in my example, the range is going to be 2, 7, and 10. A vertical line test is a way to determine if a relation is a function or not. If any vertical line passes through more than one point of the graph, then for some domain value, there is more than one range value. In that situation, the graph is not a function. And so I have an example of a graph that is a function and a graph that is not a function. And so you can see, if I was to draw a vertical line going down at any spot, my vertical line will never hit more than one point at the same time, and so that's a function. But over here, for example, this is not a function, because if I was to draw a vertical line, or if I was to take my pencil and put it completely vertically, and move it across the graph like this, if my pencil hits more than one point at the same time, it fails the vertical line test, and you know it's not a function. If it fails the vertical line test, that means for at least one domain value, there's more than one range value, and it cannot be a function. And finally, function notation is just another way to write an equation, and it is when we take f of x and function notation is when we replace y with f of x. That is how this is read, f of x. So I have an example here. This is y equals 4x. That is the exact same thing as saying f of x equals 4x. And what that is saying is y is a function of x. X is my independent variable and y is my dependent variable. Y is dependent upon what I do to x. That is what it means when we say y is a function of x. Now, sometimes it's not called f of x. Sometimes it's actually called g of x or k of x. It depends on the name of the graph. But no matter how it's written, it means the same thing. Y is a function of x. So let's go to example number 1 and let's talk about mapping diagrams. Again, a mapping diagram is just a way to determine if a relation is a function or not. And so how do I do a mapping diagram? I list all of my domain values, and then I list all of my range values. But be careful, only list them once. If any of the domain values repeat themselves, or if any of the range values repeat themselves, you still only list them once. And then what do? You map it. You actually draw an arrow from each input connecting it to its output. Draw an arrow from the input to its output. And then what you're trying to determine is, does every input have only one output? And if it does, then yes, it's a function. So here, every input has only one output. Input, one output. Input, one output. Input, one output. Input, one output. And so it is a function. But now look at what happens here. you have more than one input going to a single output. That's okay. You can go in that direction, but you can't go the other way around. And so I'll show you what I mean by that in a second. But when I list my domain and I list my range, again, be careful to only list them once. Okay, let's look at the next example. Is this a function? No, because when I list all my domain values and then I list all of my range values and I map it, what happens with this 6? I input 6 and I get 5, but then wait a second. I input 6 and then get 4. No, that's not a function. So go ahead and hit pause and draw mapping diagrams for the next two examples. Identify your domain and range and determine if it's a function or not. But remember, you only want to list each value once in the domain section and in the range section. If it repeats itself, if any of the domain values repeat themselves, you only write them once. If any of the range values repeat themselves, you only write them once. Okay, so on this first example, this is not a function because I input 4.2 and I get 1.5. But then I input 4.2 again and I get 0. So that's not a function. But this one is a function. Every input is associated with one output. Example number 2, identifying functions using a vertical line test. So on this first example, is the relation a function? No, this is not a function. Why is this not a function? This fails the vertical line test. Well, first of all, we can look and we can see I have an x value that repeats itself. So right away I know it's not a function. I plug in -4 and I get 2, and then I plug in -4 again and I get -1. So that's not a function. But the other way I can determine this is it fails the vertical line test. If I take my pencil and I bring it across the graph vertically, my pencil will hit 2 points at the same time, and so that means this is not a function. So that means for this input of -4, I have 2 outputs, 2 and -1. This is not a function. Okay, now look at the next one. This next one, it didn't give you the points, and so you have to figure out your points. And so what I'm going to do is I'm going to create values for x and find out the corresponding values for y. And so when I do so, I get this upside down U shape, which we are going to learn what this is later. This is called a parabola. And this is a function. Yes. This is a function and it passes the vertical line test. It may be hard to tell, but I promise you this passes the vertical line test, and my pencil will never hit 2 points at the same time if it goes across that graph vertically. For every x value, there is only going to be one y value. For every input, there's only going to be one output. So now go ahead and hit pause and do the on your own and identify if it is a function or not. Okay, so the first one is a function. You can see it passes the vertical line test. Each input has only one output. It's a pretty graph. We're going to get into some really pretty looking graphs. More in Algebra 2, you get into some really unusual looking graphs. And finally, this example, this is not a function. This fails the vertical line test, and you can see just from looking at the points, I plug in 0, I get 2, and then I plug in 0 again, and I get -3. So this fails the vertical line test. I have two outputs for a single input. Example number 3, now we're going to speak math. We are going to learn how to do exactly what you've been doing for a very long time, except we are going to use function notation, which is the most common form used. So it says the function w of x equals 250x represents the number of words w of x you can read in x minutes. How many words can you read in 8 minutes? So in other words, what this is saying is y is a function of x. Or you can say the number of words I can read is a function of how many minutes I've been reading. So then how many words can I read in 8 minutes? Well, I'm rewriting it as how many words can I read if I've been reading for 8 minutes? So W of 8 equals 2,000. The number of words I can read in 8 minutes is 2,000. So go ahead and rewind that again if you want to hear me say the wording again, because that's super important that you understand what this is communicating. And then hit pause and work out the on your own problem. Okay, how many words can you read in 6 minutes? So what this is saying is, how many words can I read in 6 minutes? So in other words, the number of words I can read is a function of how many minutes I've been reading. And so if I've been reading 6 minutes, I can read 1,500 words. And so this communicates a little bit more information than just saying y equals. It tells a little bit more about the story in detail. Okay, and last example, finding the range. If I say the domain of f of x equals, the domain of this function, f of x equals negative 1.5x plus 4, the domain of this is 1, 2, 3, 4, so then what is the range? So all I'm doing is plugging in each individual x value and determining the corresponding y value. And setting up a chart like this can help keep you organized, but it's certainly not necessary. But my answer is going to be this. This is going to be my range. So go ahead and hit pause and look at that to make sure you understand what I'm doing, and then do the on your own problem. Okay, so I'm doing the exact same thing. The domain of this function, which we're calling g of x, is 1, 3, 5, 7. And so then what's the range? I just plug in each individual domain into the function and I determine the range. And I just set it up like this in this chart just to help keep myself organized. You don't have to do it that way, but it certainly helps if you have trouble organizing yourself. And then your answer is going to be this. This is your range. Okay, so go ahead and stop the video, do your homework, and let me know if you have any questions.